I want to reassure that, we're going to move away from the theology of mathematics to sort of trials and ethics and things like that, which are a little more sort of historical and interesting. But I'll tell you that if you don't use it, you lose it. I didn't think I was that great at math, and I took some of these courses, and then if you don't use it, you realize. So it's a great course to take, and I want to thank everybody for putting this up. Mike, I couldn't get a photograph on you. No web presence. I'm so disappointed. But I got Bob's photograph. So thank you so much. But I think one of the purposes of all this is, they'll tell you we're going to do this, but, it's publish or perish. You got to make your tenure, you got to make all this stuff. So it's very important that you do all this and stay mentally challenged. And, in a way, I think I just on the flight in here, I read a New Yorker article by Michael Kinsley about him dealing with his Parkinsonism. And if those of you haven't read it, it's a really poignant piece. But he starts off with a Reagan joke. Apparently Reagan goes to the Mayo Clinic and they tell him, we have bad and worse news for you. And the neurologist tells him, he says, well, what's the bad news? There's the bad news, you have cancer. So what's the worst news? The worst news, you have Alzheimer's. So Reagan says, well, at least I don't have cancer. So I thought that was a mean joke, but I figured we have neurologists here, they won't mind. So, and I think this is a great piece on publication by the British pharmacologist. He says, any paper, however bad, now can get published in a journal that claims to be peer-reviewed. So, this is in 2006, and now it's gone up much more. There's 1.6 million papers in 23,000 journals. So there's a lot of stuff out there. And I thought we just do an overview of research studies. What is germane to residence? What are the simple projects you can do? Because, I'm not a basic scientist. I've never worked sort of in a lab, or I've never been NIH funded. So, but you can still do interesting things. And I think that's sort of the purpose of this. And so I thought basically I'll go over some epidemiological research, some history of these, some features of trials, and, what we can learn from this. So why do we do these studies? I think you want to collect data, you want to have a hypothesis, you want to make it better, and 25 years from now, your kids will be at cocktail parties saying, my dad had a citation index of so-and-so, and he published so much. I'm just kidding, they're not going to remember that. But the important thing is that's how you get promoted and things like that. So you look at epidemiological studies, you study distributed disease or condition of population, the factors that influence that distribution. And a lot of the public health studies you look historically came out of England. So Dahl's great paper was a cohort of physicians they studied, and they found that smokers got lung cancer. And it's very intriguing the kind of things they looked at. They looked at bus drivers in double-decker buses and conductors. And they found that the incidence of conductors having heart disease was lesser than the driver. Can anybody guess why? It's a double-decker bus, that's the hint. We climbed the stairs up and down. So they were doing more exercise, and something as simple as that led to a difference in heart disease. And I think that's the kind of stuff that I think is inspiring for us to think. So in terms of studies, you have observational studies, you can contrast between groups, you have analytical studies, experimental stuff, and then clinical trials. Not all of us will be able to do randomized controlled trials. Most of us do retrospective series of case reports. And you can look at vital statistics, you can look at data capture, hypothesis, clinical trials. So what do most of us look at? So, case-controlled studies, cohort studies, case series. And I think Fred will attest that a lot of the national database, that's a crime we can be guilty of. We've sort of looked at that. But it's interesting stuff. It's not sometimes that authentic, but you can do that, meta-analysis, survival, and of course the RCT. So some basic terminology, most of you are comfortable with this: retrospective trials, prospective, case control, cohort study, and then cross-sectional study, prevalence and incidence. So these are things that you're fairly comfortable with. Some of this is not, more sort of public health, things like medications and things. But clinical trials have a long history. So, you look at Van Helmont's study on bloodletting in 1628, and those of you who have a historical bent will know that George Washington succumbed to this trial because he died because of bloodletting. So things like that, and you look at Dr. Lynn's study on orange and limes. British sailors are called limeys because they would suck on lemon all the time to prevent scurvy. And in fact, Don Berwick, who was a Cushing lecturer at the AANS, wrote how disseminations in healthcare take so much time. So they discovered this trial that lemons prevent scurvy. It took 250 years for the British Navy to actually institute that change. So I think we're getting a little bit better. We're not taking quite as that much time, but I think it's interesting. In other clinical trials, Paul Ehrlich and Alexander Fleming for penicillin and then sulfonamide. So those were, there was the infectious disease era. And a lot of these things were very observational and interesting. I've done a seminal study on this is John Snow's water pumps in London. When they had cholera, everybody thought it was miasma. It was the air that was causing cholera. And John Snow looked at all the pump distributions and said, the cluster is from these contaminated pumps, and the water was coming down the Thames. So that sort of stuff is interesting. And, I could tell the residents, you could be looking at EVD infections. Little things sometimes can make a difference. So the core components of a clinical trial, you have to involve human subjects in time, control groups, focus on unknowns, you conduct early in development. Most of this is fairly standard. And I'm going to spend a little time on ethics. I used to hate doing all those IRB things, but they really, a colleague of mine lost his job because of IRB issues. And I think this has become a real national problem. They've become very strict on this, so you cannot be lackadaisical about it. And of course, there's a historical basis for a lot of this. So we talked a little bit about randomized trials, double-blinded, placebo, historic crossover, withdrawal trials, and the simple parts are, they get dosages, they're blinded. In blinded trials, participants don't know, double-blinded. And I think one of the great studies that came out of Houston was arthroscopy in the New England Journal of Medicine, where they did a sham operation, and arthroscopy didn't help. I think we did one on, I don't know, the movement disorder they're doing one on Parkinsonism with a sham incision. But I think those are interesting things. I think there's ethical issues on that. But if you look at these trials, you can investigate 2 or more conditions, 2 groups. You can have sample size, and I think all the math will be going over. They'll cover a lot of that. But if you're going to recruit patients for a trial, you want to know things like, explain the study, informed consent. All the residents are probably involved in some head injury trial or something, and you cannot be cavalier about that. It's a very strong ethical responsibility. If you do a protocol violation, it's like, this guy's a drug addict, he's off the streets, in the ghetto, nobody knows him, we just signed him up. Hell, we're running the study. Done. You're over. You know what I mean? You have to be really strict. Follow this very closely, and once it's safe. Now, quickly, in terms of phase 1, phase 2, phase 3, can anybody tell me an example of a $1 billion drug that came of the is the BMP. BMP became a $1 billion drug. So there's a lot of scope for these, but you'll be surprised at how few of these drugs really make it. You read a lot about in the press, my God, Amgen's buying this company for $9 billion, somebody else is buying something else. The vast majority of drugs don't make it. It's like startups. Everybody says, oh, this startup is great. I'm going to start Googling. The vast majority of any of the tech startups don't make it. They die. 99% die. It sounds great, sort of good, but so again, phase 3, phase 1, phase 2, you can give larger series, and but the success rate is what I'd like you to look at. So phase 1, about 70% of the drugs will work. Phase 2, 33%, but even at phase 3, only 30% of the drugs will make it commercially. So it's a small, if you look at the way it cuts down, and this is just to show you graphically how it moves up phase 2, phase 3. And again, we really don't have much to do with that. I think the great place where drugs, the god that failed is in stroke, because we haven't really come with anything new. We've cured strokes in rats, but we haven't done it in human beings, so little mood breaker there. Quickly about crossover designs, there's a washout period, again, another kind of crossover trial. And then just the legal and procedural aspects, if you do a clinical trial. And I always feel, try simple things, things like, anosmia after a pterional craniotomy, olfaction, what happens to olfaction. I always think simple things sometimes can take a step forward. So you have a study design, ethics committee clearance, you want informed consent, collection of data, report writing, and then these are sort of the ethical principles. There must be justice. You can't be paternalistic, and some of the ethical norms that are there, proper use of placebo, competent investigators. And people always wonder, well, why are you so ground up on all this? Why is this so important? And why is the IRB all this? Because there's a history of abuse. I mean, I think you look at Dr. Mengele and what was done there in terms of identical twin studies, it was grotesque. So that is something you're always, always very cautious about, that there is none of this abuse that happened. And in this country, when you think of the Tuskegee syphilis study, you know, in 1952, they knew these patients had syphilis, and they withdrew treatment for them for academic advancement. And that was egregious. It was criminal. But it went away, and that's why we are so careful. And I think one of the largest, the worst stains neurosurgery has had is that lobotomies were something that was, you know, there was, Freeman and Watts were doing 30 lobotomies. They'd go to these asylums and do 30 lobectomies in a day. Because there was no Thorazine, there was no medication, and you know, Ted Kennedy's sister had a lobotomy done in DC, and so this is Freeman and Watts. So this was a real sort of tragic stain. You know, they felt it was the right thing to do. There were no studies to show it worked. So as much as we have pride in our profession, we should have, this is a stain that affected all of us. This is just to see how they would do it. They would do 25 people this way. So this was sort of a bad thing to do. And I think more recently, Wakefield's thing on autism and the MMR vaccine, you know, he fudged this data. This was published in the I think it was BMJ or Lancet, where he said that the vaccine causes autism. And this is a wonderful editorial they wrote when they retracted the paper. They said, you know, tens of millions of dollars children were injured, hospitalized, and most tragically died. Tens of millions of dollars were wasted on repeated research studies to refute Wakefield's contention of an association between MMR vaccination and development of autism. Time and attention were directed from rational scientific pursuit of more reliable and probable cause of autism towards a fatally flawed notion. So this guy turned the clock back. So this was bad science, unethical, was accepted, and there's still parents in this country that believe that this vaccination will cause autism, and it's tragic. So just again, one of the reasons we're so careful on ethics, and that's, you know, you have to be really cautious, you have to be very ginger about this, and the feds have all kinds of things. And I know it's annoying doing all the IRB protocol, I gotta fill this stuff out, but I just wanted to give you a little historical perspective as to why this is important. You know, as Santayana said, those who forget the past are condemned to repeat it. You can't make these mistakes again. Just to show you some of the governing bodies, you need to DHS, Human Research Protection, NIH, Federal Wide Assurance, Federal Register, ICH. There's a lot of mnemonics here. But you deal with these, IND, you know, drug investigation, brochure. And, you know, I think with the artificial disc study, they went through all this stuff. Spine tends to use more innovative things. So I think they have that stuff. This is just approval to the investigators, IRB responsibilities. And, you know, I think the key points, again, are you must have consent. You must explain it well. As residents, you're going to be on the front line for a lot of these studies. You know, it was, you know, whether it's a brain tumor at a university or it's head injuries, everybody's involved in this. I think you really have to be very cognizant of this, yeah. Again, IRB, this is when they changed it in 2000. We had a major overhaul of our IRB, and it was a very traumatic thing to go through. We all had to go through hours of study and stuff, but I think it hopefully makes it safer, and we want to make sure they understand it's voluntary. And I think one of the reasons you want to be careful about all this is a vulnerable population, women, and a lot of the studies did not have this study done. And like, you know, at least in Louisiana, we were using prisoners in these studies, and you can't do any of this stuff. So we had to really sort of come back and be really cautious of this. And I think some of the problems, like there's not much study because women were historically excluded from all these studies. So like with aspirin and stuff, now I think the NIH is really focusing on having more studies on women's study group. And you should look at most of the studies, majority of women were sort of excluded on that, yeah. I'd like to go through some trials in neurosurgery just to give you sort of a broad overview and to sort of see, you know, what are the participation in clinical trials. You know, they want to give back to the society, it's support others, but there's other people that are very skeptical. I think we've seen that with the African American community giving for transplantation. I mean, they will not give that, especially in our state. We have big issues with that. So there is a lot of, hesitancy about this, yeah. What I thought was perhaps take a few studies in neurosurgery, sort of a historical odyssey, and to tell you how some of these things came. So Wiley McKissick was sort of, he was the baron of clinical research in Queen Square, London. And he was a really fine surgeon, worked very hard, but he did some of the seminal papers. So you look at hypertensive hemorrhages. I know Mendelow's doing stuff, and I think Awad has another trial going. But he was the first guy that said it doesn't make any difference. Hypertensive hemorrhage, you can take them out. And he was the first person to come with the aneurysm studies. Kind of poignant. ISAT should happen in England. The first study actually came from there too. So this was the timing of aneurysm study that I think that was out, and they looked at, again, this was just timing. It was class 2 evidence. There was no randomization. They looked at about 3,000 patients, 6-month follow-up, and the aim was very simple. Define a relationship between timing of aneurysm surgery and outcome. And they had good primary endpoints. They defined good secondary endpoints. And so the results were important. I think this had an impact on what we did neurosurgically. And surgically, patients did well. And basically, 75% of those admitted within 3 days were in good condition, 58% had good recovery at 6 months, and about 25% death rate. So this was not a randomized control, but it was an important study, and it advanced what we did. Now, this is Roy Patchell, the neurologist will be happy. I have him on here today. But this was a great study on metastatic disease, a landmark paper. And he didn't have a lot of patients on this. I think it was either 50 in each arm or 25 in each arm. But this really changed the paradigm. I mean, I just finished my residency that time, and the radiation therapist would say, oh, no, everybody needs brain. You don't need to take this out. So it changed the practice. And I think that's why it was a great paper. It's 48. There's 25 in each group. There's not a lot of patients. But I thought an excellent study where they showed very good results. And I think, hopefully one of you will do something like that and affect our practice of that. Yeah. Now, the nimodipine study was very good, too. I think there was versus placebo with a good stratification. And again, this is something you do on all your subarachnoid patients, but again, a trial that impacted practice. I don't want to go much into the ISAT study, because you can labor about this, but I think with the ISAT study, I will caution us, we as neurosurgeons had more of an ad hominem response to this. I remember going to meetings and saying, well, in England, they don't know how to use the microscope there. How can we trust these results? And I'm like, seriously? They know how to clip aneurysms. But it was sort of this, well, really, these don't apply here. But the truth of the matter is, when a study like that comes out, it effectively changes practice patterns globally. You think about it, before ISAT came out, 90% of aneurysms were clipped in this country, and today it's 66% or 65%, 35% clipping, and it's only going to go the other direction. So I think that's an important try. You may disagree with it, but and there were issues with it. You can say, enrollment rate was not good. Most people didn't go in. But, the BRAT trial subsequently confirmed this, that it wasn't that clip was superior to coiling. So these are this is the relative risk reduction that he talked about. This was the paper I really wanted to talk to you guys. This is a resident who came up with this idea. Okay, this guy Centarius was a resident at Queen Square. And I never used to put drains in chronic subdural hematomas, never, okay? It's like, it's a wimpy thing to do. I just drain it out, they're going to do great. So this kid thinks this up and said, he just did a survey in England with all the centers. They go, are you guys using drains? You're not using drains? No. So he found a wide disparity between those who used drains and didn't use drains. So he comes up with this trial, does this trial. This gets published in Lancet, a very high impact journal. And I think this is the kind of inspiration that the residents should have. He thought of a simple project, he executed it, it changed the practice of neurosurgery. Today, everybody puts a drain when they drain a chronic subdural hematoma, period. So this was not a big biochemical transferase thing. He didn't do anything complicated. He looked at a simple question, simple answer, and changed our practice. And I think that's what we really need to congratulate him about. It was like, you know, in all these patients, you look at the numbers, all added up, and their basic conclusion was this works. And I think everybody today puts a drain in, you know. So I want to end with two things that I want to concentrate on again. I think ethics is very, very important. Ethics, and if you look at this, this was a review of retracted articles. I don't know if you're aware, but there was one resident, and we had several instances, a resident that indulged in wholesale plagiarism, took out articles from a Canadian journal from the 80s and put it verbatim in his publications. Till the original author was like Googling himself, like, hell, I wrote this stuff, where did this come from? And so the whole thing was retracted, it became, you know, a big problem. And then, you know, in a developing country in India, there was somebody putting these spacers in the neck, and it became a huge scandal in India where they were like, this data was cooked up, it wasn't correct, and it was a big issue. So those are things, you know, if you look at this, the retractions are from misconduct. Like you would think it was some research issue, the dog died young, the IV didn't work, you know, Geiger counter wasn't working or something like that. But just 47% was clear cut. And I think most of you will remember Dr. Hwang Suk Ki, who was on the fast track for the Nobel Prize in Korea. I mean, he was this brilliant guy. Everybody was naming their kids after him. And his cloning data was completely fabricated. And it was like a, you know, precipitous fall from grace. So I think that's something we should be extremely cautious about and be, you know, airtight. I mean, David Baltimore was a Nobel Prize winner, and, you know, he had, Dingell did a whole investigation in the guy and said, oh my God, this could be fabricated. Teresa Jimenez, she was the Brazilian collaborator. He lost his job. He was subsequently acquitted. But, you know, it's a traumatic thing to go through. The other thing I want to tell the residents before I end is rejection. Get used to rejection. Even at my level, at our level, we write papers and they get rejected. They get rejected again and again, and you get mad about it. So I like this quote from Hampton. He says, you know, a writer, what does he think about critics? What do you think about the editor? They feel like their lampposts feel about how they feel about a dog. Well, it's not that harsh, but what I'm trying to say is that you will get rejection. Nino Chioco is a good friend, and he always says, Anil, rejection is a part of life. Every day we get rejected. Somebody slams a door, somebody says this is not good, this is not bad, and you're going to get that with your papers. But you have to be relentless. I think you got to keep trying. So in conclusion, I think clinical trials yield important results. You have to follow guidelines and protocols. You may hate your IRB, but it's important. And I think ethics is extremely important. You want to make sure you just don't trust a medical student to pull your data out or somebody else. Because you know what? You look at it and it's like, my God, this is cooked. This ain't right. So you have, you trust but verify. You have to verify the stuff and double check it. You know, what is that? David Lee Roth was the rock star. What is the guy who does, what is the band he ran? Yeah. Van Halen. Wasn't it Van Halen? Yeah. So this is an economist, he quotes this guy. He said that he used to have a 53-page contract every time he did a rock concert. One of the things he would put in the contract is in the backstage, I want a box of M&Ms, but I want no brown M&Ms in there. It's like, what's this guy, crazy? Why do you want to make sure there's no brown M&Ms? Anyway, they do. The first thing David Lee Roth would do when he went to a concert, he'd go backstage, open out the M&Ms. If they were brown M&Ms, he knew they hadn't read the contract. And I thought that was brilliant. He was so detailed. I mean, you'd think I was a rock star, he's all doped out. No, he was checking the M&Ms. And he said, they're not following the contract. So the new Freakonomic guys, that's in their book. So I think it's going to make a good read. Well, thanks so much, you guys. Yeah.